Good morning, my algebros. Here we go with our last lesson in chapter 8 of putting all these parts together and graphing quadratic functions. So we're going to look at 7 steps today. The first 3 steps, we're going to kind of set it up for success here. We're looking at this quadratic equation of y equals x squared minus 2x minus 3. The first thing we do is check to make sure it's in standard form, or y equals. And then we see from the equation, does it open up or down? And because it's positive, we know that it opens up. Next, we find our axis of symmetry, our negative b over 2a. And in this case, it'll be negative 2 over 2 times 1, which turns out to be a positive 2 over 2, which is just 1. Now we need to find the rest of the vertex because we can solve for y, and we get y squared minus 2 times 1 minus 3. We just plug in the x value that we found, which was 1. So then we get 1 minus 2 minus 3, kind of funny, huh? And we get negative 4. Now we have our vertex. Now what we do, just reminding us of our equation up there, is we make a table. And we no longer do negative 2, negative 1, 0, 1, 2 because we know the vertex. So we have to find the vertex first because that has to go in the center of our table. And that way our parabola will show a very even shape because we've started in the middle. Then of course we want to do some points that are bigger and we want to do some points that are smaller. And what do we know about these points that we've put in here? Well, I know that if x is 0, then it's going to be the y-intercept, which we know is negative 3. And that means I know that on the other side it reflects that. So I haven't even had to solve an equation yet. It's pretty cool. Now I can decide, do I want to plug in the negative 1 or the 3? I'm going to stick with a positive number and go 3 squared minus 2 times 3 minus 3, which gives us 9 minus 6 minus 3, which gives us 0. And then I know that reflects on the other end. Now I'm ready to graph. Go ahead and move my points over here that I just found out. And I graph those points. Now the last step here is labeling our parabola correctly. We start with labeling the vertex and the axis of symmetry. So our vertex is 1, negative 4. And our axis of symmetry, we go ahead and do a dotted line up there. It's there, but it's kind of invisible, but we know it's there. And we know that it's the x value of 1, so we say x equals 1. And then we're going to also label our domain and our range. And we know all the domains are always all real numbers for quadratics because the x values would just keep going and spreading out forever. It doesn't matter whether they're positive or negative, it's always all real numbers. But the only thing that's limited is our range. And we know that y equals negative 4 because that's where it starts. And on this one, it can be bigger than negative 4. And we call this a minimum because I like to say it has a minimum amount of negativity because it's a positive parabola. All right, that's your sample. Now let's go ahead and walk through one together. Go ahead and write this one down. And we'll start by checking off our things. Number 1, is it in y equals ax plus bx plus c form? And yes, it is. So we know we've done the first step right. If not, we'd have to manipulate it so it does. Does it open up or down? It opens up because it's positive. What's our axis of symmetry? Well, we use our axis of symmetry equation, which is x equals negative b over 2a. And I plug in, I have negative 6 over 2 times 1, which is going to get us to negative 3. Now I go ahead and find the rest of my vertex. by plugging in the -3 for x and solving for y. So y equals -3 squared plus 6 times -3 plus 5. Then I just get 9 plus -18 and plus 5, ending us up on a -4. Now we're ready to make a table. We make our table and we plug in our vertex here. We do 2 points that are greater, so greater than -3 is -2 and -1, and then smaller will be -4 and -5. Now on this one, we have to plug in the points to solve. So if x is -2, we plug that into our equation, and we solve and we get -3. We know that reflects on the other side of the vertex. Then I go ahead and plug in -1, and I know that reflects again on the other side. I can graph my points. And label. I have my axis of symmetry, x equals -3. I have my vertexes there. I have my domain is all real numbers, and my range is -4 or greater than that. So greater than or equal to -4, which is a minimum. I know I kind of went through that quickly. When you're doing it, you should, pause the video as you need it, obviously. Okay, one more. This is going to be your you try. So go ahead and do this, pause the video, and try all your 7 steps, and then check your solutions. Okay, first I check to make sure it's in y equals, and it is. And is it up or down? Well, it's going to be down because it's a -2. Axis of symmetry, -b over 2a will be -4 over 2 times -2, which gives us 4 over 4, which is 1. Solve for our vertex, plug it in. -2 times 1 squared plus 4 times 1 plus 3 will give us 5. Now we make our table, starting with our vertex in the middle and doing points that are bigger and smaller. And on this one we see we have that 0, so we know that's the first one to plug in because it's easy. We know it's the y-intercept of 3. And it reflects. And then I'm going to go ahead and plug in 3. -2 times 3 squared plus 4 times 3 plus 3. And I get -3 and it reflects. Then I graph. And you can see this makes a negative parabola. And I label my axis of symmetry. My domain is all real numbers. And my range can be 5 or less than 5 because it has a maximum amount of positivity. Whoop. It has a maximum. Right? All right, if you'd like to do the next you try, you're welcome to it. Just one more practice, or you can just get to the homework. Okay, let's graph and label. Pause the video and then check your work. It opens up. And that's my x value. My axis of symmetry is 3. Plug in to find for my vertex. And I make a table. And I draw. And I label. Alrighty, here we are finishing up. See you soon.